Today's lesson is on properties of radicals. There's two properties of radicals. The first property that we're going to go over is the product property. The product property. That property says the nth root, there it is, the nth root of AB can be split up as the nth root of A times the nth root of B. So that's the product property. You can split it up. Or, if we need to in the end, when we're done simplifying, we might go ahead and multiply back together some of the numbers that are under the radical sign. Okay, once we've simplified completely, I'll explain that a little bit later. Here's an example. Go ahead and put product property. I'm going to go ahead and put that in yellow because it is defined there. And then my example I'm going to put in orange. We're going to do this. We're going to say the fifth root of 64. Well, that can be split up as the fifth root of 32 times the fifth root of 2. Now, I know that the fifth root of 32 is 2, and I'll show you how to find that if you don't know them. I happen to know that one, so I'm going to get a 2 from here. This is just going to give me a 2. This one I can't simplify any further because it's just, 2. 2 is prime, and so there's only one of them, and I'm looking for 5 of them, and I only have one, so I'm just going to go ahead and rewrite it. This right here is my answer. That's it, simplified. So we took it, we used the product property, and we broke it up. I broke it into something that I knew was a fifth root, and then I had this guy left over. Okay. There's something called simplest radical form. And they're going to ask you to put it in simplest radical form. Well, when you put it in simplest radical form, this is one of the pieces that has to be true. No radicand. Okay, no radicand contains a factor other than 1 that is a perfect nth power. Okay, simplest radical form. That's just one of them. Okay, so this is one of them, but there is going to be another one that we're going to talk about when we look at the quotient property. So this simplest radical form, that pertains to this one. Let's talk about what that really means though, because sometimes it just sounds like a bunch of words. So let's look at the fourth root of 162. So I'm going to look for the fourth root of 162. Okay, a fourth root. You know what? I don't know all of those. So I'm just going to start breaking this guy up. So I have a fourth root of 162. I know 3 goes into it. I can tell because 6 plus 1 is 7 plus 2 more is 9. 3 goes into 9, therefore it must go into 162. So I'm going to pull out a 3, and then what I'm going to get is 54. Okay, good. Well, you know what? That doesn't help me because that's not a perfect fourth root, 54, and neither is 3. So I'm going to have to split it up some more. Well, 54, I think I remember that from my multiplication table, is 9 times 6. 9 times 6. Still, that's a perfect square, but that doesn't help me because I'm looking for a fourth root. So perfect square. Not any help. I have a 3 here, I have a 6 there. Well, you know what? I'm going to have to break it up again. And I'm going to break everything this time. So the 3 I just had there, here it is. The 9 is breaking up into 3 times 3. And the 6 is going to be 3 times 2. I've broken it all up to prime. So now that I have prime, I need 4 of something to pull 1 out. Well, if you look, I have 1, 2, 3, 4 3s. With my 4 3s, I can combine them all together into one little package, and outside my radical sign, I'm going to get a 3. It comes outside. But I have this one left right here. He didn't have anybody to join, so that 2 is just going to stay right underneath the radical sign. My answer here is going to be 3 fourth root of 2. There's my answer. If you look, here's my purple 3. It's right outside. My 2 stayed under the radical sign, right? It's still under there. He's right there. I brought him back in. So I have 3 fourth root 2. Good. Okay. Well, they don't just give you numbers. We like to give you letters. We're big on letters, big on variables. So let's look at this one. I'm just going to give you a variable. How about, and here was an example. Sorry, I didn't label it. There was an example. And I'm going to give you another example with a variable. And then we're going to put it all together. I'm going to say the 5th root of x to the 7th. The 5th root of x to the 7th. I need to simplify it. I need to put it in simplest radical form where there is no radicand contains a factor that is a perfect nth power. Well, here what I have here is this. I'm going to show you 2 different ways. I have the 5th root of, I'll show you this way first. There's 1, 2, 3, 4, 5, 6, 7. I have 7 x's. You see that? There's 7. I wrote them out here. This is the number I need to bring just one of them out. Just one out. So what I'll have then is 1, 2, 3, 4, 5. There's my 5. I'm going to bring them out, put them in a package, and what I'm going to get is 1x on the outside of the radical sign. But I have these 2 x's left, and they're going to stay right underneath that radical sign. So what I'm going to end up with is x. Here's my purple one. Came out. 5th root, and I have 2 of those x squared. So there's my 2 x's. Okay, that's one way you can do it. The other way you can do it is this. You can say the 5th root, I'm just going to use the same one, the 5th root of x to the 7th. I can split this, and I just learned that that 7 could be split as x to the 5th times x squared. I can split that up. The fifth root of x to the fifth times the fifth root of x squared. Well, the fifth root of x to the fifth, that's my x, right? The fifth root of x to the fifth is just x. There's 5 x's in there. I need 5 to get 1 out. There's my 1. Nothing I can do with this. There you go. So here's my answer. 2 different ways. Okay. Probably you're going to start here. Once you get it, then you'll go right to this one. And once you really get it, you'll be able to just look at it and figure out what it is. So here's an example with a variable. But now what I would like to do is, I want to put it all together. So this is an example with everything together, everything that I can throw at you here. Okay, how about this? Let's go cube root of 375a to the fifth. Okay, I have 2 things that I'm going to have to work out. I have this 375 that I'm going to have to split. So I'm going to go ahead and split it. Cube root, I can tell 25 goes into 375, right? And that goes in, what, 15 times? So I have 25 times 15 times a to the fifth. Okay, well, I can split that up a little bit more. I have cube root 5 times 5 times 5 times 3, all of it split up, and I have a cubed times a squared. Right? When I multiply my bases, I add my exponents. That would give me 5. Okay, well, what I'm looking for here is I need 3 of something. 3. Well, I have 1, 2, 3, 5s. So those are all going to combine together to give me a 5 on the outside. This one, I could split up and say a times a times a, but I don't think I need to do that. I have 3 a's sitting here. It's like text messaging, so you don't have to write them all out, right? Used to be called shorthand, but we changed the name as we changed generations. So this, just taking this to the outside, is going to give me just a. Now, what do I have left in here? Well, I have that 3 left in here, and I have that a squared left in here. Those are going to stay under the radical sign. These just came out. So I have 5a cube root 3a squared. And that's my answer. Remember to pause the video if you need to take notes. You can replay it. You can do whatever you need to do. Get the notes down. This was an example. We'll go ahead and put that in orange. We have a lot of examples right now. 3 for 1. That's what we need. Here's another way you can look at it if you want. When you're taking the variables anyway. Let's say I have, I'm going to go the third root of x to the 10th. Okay, and I need to split that up. Well, here's how I was showing you. I would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and who wants to do it this way? Nobody really, but here you go, just to explain fully what it is we're doing. I need 3 to take 1 out. 1, 2, 3. I can take 1 out. Oh, but look, I have a bunch left. I could take out another set of 3. 1, 2, 3. I'm going to get another x. Oh, look, I have more. 1, 2, 3. I can take another x. What I have then is this guy left underneath. Can't do anything with him. And my answer, I have 1, 2, 3 x's on the outside, so I have x cubed, sorry, there should be a cube there, cube root of x, because that's what I have left. Now, here's the other way you can look at it. You can ask yourself this question: how many sets of 3 are there in 10? So here's the question: how many sets of 3 are there in 10? How many sets of 3 are there in 10? Well, you know what? There's 3, right? There's 3 sets of 3 in 10, right? Here they are. That's where I get my x cubed, and then I have 1 left over. 3 sets of 3, that's going to give me 9. I have 1 left over. And we'll talk about that more in class. But just so you know that, you might want to ask yourself that question. That's just kind of one of the steps. And I'm going to go ahead and put that in blue. And we'll talk about that more in class. Okay, let's get to the quotient property.